Hi, class, and welcome to chapter 10. All right, chapter 10 is very similar to chapter 9. It's just that for 10, we are now talking about hypothesis testing for two means, hypothesis testing for two proportions. All right, so we are looking at not just one mean compared to a value, but now we're going to be comparing two means to each other or two proportions to each other. We're going to talk about three sections in chapter 10. The first two are going to be about means. Well, actually, I think we go mean, proportion, mean. All right, but the means are split into two subcategories. We have independent samples. Independent samples are samples that are not in any way related to the values selected from another population, meaning that you're two completely separate. Good example for this could be something like heights of men and heights of women, right? You have no overlap in your samples. They are fully separated. It doesn't matter the order in which you list them. We have them just two fully separated. Whereas matched pairs, the other kind of means we're going to talk about is when you have two pieces that are tied together in some way. I think an example that comes up later is talking about someone's eyesight in each of their eyes, their left and their right eye. In this case, we would have a list of data for each person. You know, subject A, we would have their left eye and their right eye, and we would need to keep those in line to each other because we're comparing their differences. All right, subject number two, we would need their left eye and their right eye. So we couldn't just throw all the left eyes into one column and all the right eyes into one column in whatever order, because we need those pairs to be grouped together. Right, that's an example for matched pairs. We'll go over others later. A lot of the time when we're doing matched pairs, we're talking about like subjects of some kind of medical test or some other kind of experiment where you have a before and an after piece of data, again, for the same person, so they need to be paired together. So those are the two types of means. Again, we will also be doing two proportions, and those will be independent. So three sections overall. We are starting with those independent samples for means. So let's talk about that. Let's just dive on right in. So our requirements for independent samples, they need to be both selected in a simple random sample way. You'll see a very similar characteristics, similar requirements for all of our other tests. Okay, there's a reason we discuss these so early on in the chapters. They need to be gathered in a random type of way, right? Simple random samples. And the populations here need to be completely distinct. We can't have an overlap. Men and women fully separated, whatever the situation may be. There can't be a possibility that one person was interviewed or studied for both samples. They need to be fully separated. So two distinct populations. If the sample size is small, when we say small, we generally mean less than 30. All right, if it's small, the distributions have to be normal. You have to know that going in. If the sample size is large, greater than 30, let's do n, it's less than 30, n is greater than 30, then it doesn't matter what that distribution is. That normal distribution, that law of large numbers, it fits in as long as we have a sufficiently large sample size. So samples need to be randomly selected. They need to be large enough, or you need to be stated or told that the distribution is normal. Again, in chapter 9, we had mu compared to a number. Right? Chapter 9, we had our null hypothesis could be that mu was equal to 4. And our alternative hypothesis could be that mu was greater than 4. Okay, here, we're not going to be comparing it to a number. We're comparing the means to each other. So we're going to have one average equal to another. Or sometimes it can be written in this way. So these are the same statements. If I were to subtract that second mean over, so I'm just going to write this under here this first time, and then I'm not going to write it again on the others. If I subtract that to the left, that's mu1 minus mu2. I can't combine those because I don't know what those numbers are. And what would be left over here is a 0 because I subtracted that number to the other side. So these are equivalent statements. These are the same as each other. It's just two ways to write one of our options for a null hypothesis. Another option is that mu1 is greater than or equal to mu2. Or mu1 minus mu2 is greater than or equal to 0. Mu1 is less than or equal to mu2. Or mu1 minus mu2 is less than or equal to 0. Again, all of these options are the same statements, the same equations as what's over here, or inequalities. It's just we rewrote it where we subtracted that mu2 to the other side, and we get 0 because of that. Well, so these, I mean, I showed them right here really quick. It's more of just the transition to show the difference in what we did in chapter 9 to what we're doing now, right? These would be our H naughts. Our HAs would be the same. It's just that we would be doing, oh, I think it's less than, oh, I think it's greater than, oh, I think it's not equal to, right? We're changing the sign the same way we did here. It's just, again, it's not a number that we're comparing it to now. It's each other that we're comparing it to now.